The Arizona Game and Fish Department and U.S. Fish and Wildlife Service have been working for the past 44 years to recover the Mexican wolf population that nearly went extinct.
But our reporter Dylan McKim learned that as the wolves started to come back, scientists are encountering a new problem.
There were only 7 Mexican wolves left in the wild in the 1970s. Now, in the latest wolf count, that population has swelled to at least 131 wolves. Now, although this is an amazing achievement, scientists are facing the problem that they only had 7 sets of genes to repopulate with, leaving the wild wolf gene pool far too similar. A team from the Arizona Game and Fish Department is heading out. They're looking for Mexican wolves.
Primary objective for this operation is to get a good count of the wolves that are out there.
But they have another goal in mind, too. Catching one.
Yeah, every animal we capture in the wild, whether it's a dog or a coyote or a wolf, we'll do a genetic analysis on it.
The team is successful today.
Excellent. Well, his heart rate's running around 90.
His name is MP-1858, a 10-month-old pup. And the blood sample taken from him today will go towards solving a problem facing the Mexican wolf population.
Our wild population right now is pretty inbred or pretty related.
The team is concerned with increasing the genetic diversity of the packs of Mexican gray wolves, which means they don't want 2 wolves whose genes are practically identical. According to the government's 2020 recovery plan for the Mexican wolf, 11 of the 26 known packs have a higher than normal chance of inbred pups.
So the way we're addressing genetic recovery of the wild population is through cross-fostering right now.
Cross-fostering is the process of taking a captive-born pup and placing them in the den of a wild pack. The process begins over 1,000 miles away at the Endangered Wolf Center in Missouri.
We know the genetics of every single individual in the captive population. And what we do is we make sure that the animals that are paired together not only are good genetic matches for each other, but help keep the overall population healthy.
It's a painstaking process that MOSSOTTI says has its limitations.
The stars, the moon, the planets, everything has to align to make it happen. And I say that because we have to have a wild mom that gives birth about the exact same time as a captive mom.
At least 9 of the 22 pups fostered into the wild have been found alive after 1 year, with 4 of them producing pups of their own, leading some to believe fostering doesn't go far enough.
It can only be done on a pretty limited basis.
Sandy BAHR is with the Grand Canyon Sierra Club and is a part of a larger coalition of conservationists and scientists that are suing the U.S. Fish and Wildlife Service, believing there needs to be more done in the recovery program, including releasing adult wolves from captivity.
We think it needs to be augmented with the release of wolf packs, and particularly with an eye to the genetics of those wolves.
But according to the 2020 plan, there are no plans to release adult captive wolves this year, claiming captive adult releases are not as successful.
A lot of the behavior that we see from releasing an adult wolf, where it takes them maybe 4 or 5 months to get their feet on the ground.
For now, MP-1858 is released back into the wild. His blood sample is sent to the lab to be analyzed, helping biologists get closer to their goal of full genetic recovery.
But it'll be nice one day if we can get the genetics up to where they need to be able to kind of step back and let wolves be wolves.
Captive facilities had also been collecting semen samples for over 20 years in hopes that technology would one day allow them to use it. And just a few years ago, scientists at the Endangered Wolf Center did the first ever artificial insemination and were able to have a healthy Mexican wolf pup, allowing MOSSOTTI and her team to reintroduce genes that had once been lost. In the broadcast center, Dylan McKim, Cronkite News.